In Unit 6, we're going to continue reading in Chapter 3. So we want you to read Chapter 3, pages 68 through 73. And this is where we'll get into actually working through the method of using truth tables to evaluate for validity. And your homework for this unit is to do exercises 3.8, and so that will be on page, exercises 3.8, which will be on page 70, and want you to do 1 through 12. So that's about 12 truth tables. That's going to take you. That's going to take you a little bit. So you may want to do a couple a day to kind of stay consistent. Kind of keep your mind on these things. And with logic, especially in this propositional, formal, and then symbolic stuff, it's something you got to kind of chip away at every single day, because if you don't use it, you'll lose it. So that is 3.8 on page 70. 1 through 12 is the exercises that are due by the end of this unit on Sunday at midnight. So kind of getting into the lesson. The kind of big picture purpose of truth tables is that before this other method was developed, which we're going to learn, which is doing proofs, this method was developed to show that under no circumstances, it's shown to prove validity or invalidity. And the way it does that it shows under every single possible configuration or output of truth values, given the number of possibilities of truth values of the atomic statements and the logical connectors and truth function of those connectors in the argument, that there's no circumstances under which all the premises are true and the conclusion is false. So if there is a line in a truth table where all the premises are true and the conclusion is false, then you have an invalid argument, because it's not possible for a valid argument to have all true premises and a false conclusion. It will necessarily have a true conclusion. That's what it means to be valid, that if all the premises are true, the conclusion must be true. And so one way to kind of get into this, there's the method of setting up a truth table, and in doing the method, we will be learning how they work and what the purpose is of them. So kind of starting there on page 68. What you want to do is look on page 69. There's an example there of an argument we know is valid because it is actually invalid because it's a fallacy, a formal fallacy. If you want to see what I'm talking about, turn to page 69 in the textbook and look there at the bottom. And so we have an argument here, which is, it says A, if A, then B, B, therefore A. So that could be an argument that someone makes. And the way you set up a truth table is you draw a horizontal line and a vertical line, and you list the atomic statements that are in the argument. Here we only have two. We have A and we have B. So you have A and you have B. They substitute there for these variables of P and Q, these free variables, and but I'm going to keep it A and B. So you have A and B, and what you want to do is then you write the premise. You write the premise. Then you have a space. You write the next premise, premise 2, which is B, and then you write the conclusion, which is A. And because we only have two atomic statements here, the way you determine how many lines you're going to have is you take the number of atomic statements. You take the number of possible truth values, which is 2, and you square it by the number of atomic statements. So you have 2 and you have 2. So that's 2 times 2 equals 4. So you should have 4 lines. And you start off by saying true, alternating, true, false, and then you work from, as you're looking at the paper, you work from the inside out. And when you work from the inside out, you start off by saying true, false, and then you start alternating by twos, and you go true, false. There, that way you've set up every possibility of the combination of those truth values of those atomic statements in the argument. Then you go over and you start applying those truth values to the atomic statements of particular premises by themselves, and coming up with the truth value based on the logical operator. So you say true, which would be true, and then B we know is true, and A we know is true because they're right there. Then true, false, what would be true, false there? That would make that false, and then we know there's a false because B is false here, and then A is true here. Then here you have F, and T, so you have F, if F then T, that's true. So you're applying those up here, to these, and then to right here. Then we know B is true, so you put the true there, and then A right here is false, so we put false there. And then false equals true. Then we know that this B is false because it's right here, and then we're pretending that's right there. So B is false, and then A is what? False. Right there. So the question is, when you look at this, you ask yourself, is there a line where you have all true premises and a false conclusion? And there is right here. So that means that this argument is invalid because because you have a line where you can have all true premises and a false conclusion. And if it was a valid argument, that wouldn't be possible, because in a valid argument, if you have all true premises, you have a true conclusion, necessarily. So if you have a line where there's all true premises and a false conclusion, that means that this argument is invalid. Okay, so that's one with two. That's one with two atomic statements that are in the argument: A and B, B, A. Okay. Now you'll get to a little more complex arguments. So you'll have some that may have three atomic statements. So let's take this one for example. Let's say premise 1 is A. If A, then B. Okay. And this is actually your conclusion. Someone's trying to argue this. A. Okay, so this is your conclusion here. The way you would set this up is how many atomic statements do you have? You have one here, and one here. You have A, B, and C. You have 3. Okay, so if you have 3, you'd set it up like this, the same, horizontal line and vertical line. And you have 3, and you would list them really in alphabetical order, A, B, C. Okay. And now see how this time we have 3 atomic statements. We have 3 atomic statements. So the way you calculate it, like I said above, is you take the number of truth values, which is 2, it's true or false, and you square it by the number of atomic statements which are 3. Okay? And so you have 2 times 2 times 2, and that equals 2 times 2 is 4, or 4 times 2 is 8. So we need 8 lines. And you start off by alternating. You start, remember, from the inside out. Okay? And you start by alternating true, and we know we need 8. So true, false, true, false, true, false, true, false. And as you can see, this can get cumbersome the more atomic statements that you have. And that is why in the next lesson, we're going to learn how to do abbreviated truth tables. Okay? So you go true, false, true, false, true, false, true, false. The next one, you go true, true, false, false, true, true, false, false. And then for the next one, you go true, 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 false, 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 false. And so as you can see, this can get cumbersome, okay? And that's why we're going to learn, after you master this, we're going to learn a quicker method. All right? So you put the premise, remember, A, if A, then B, if C. And then you'll have, your conclusion over here, which is if A, B, or C. All right. And so sometimes people will start assigning the values of the row in here like this. As you can see, A, B, C, A, B, C, and then right here. And then start calculating the truth values of these statements. But it may be easier to do it in your head or do it in a way that you can identify the main logical operator. So you could do it like this, but remember we work from the smallest unit out. And so the main logical operator in these two statements is this horseshoe. So you start with these smaller compound statements that are in the parentheses here and work out. And so you have true with this. You have true with this horseshoe here. So that's going to give you a true here. And what's a true and a true with the horseshoe give you? That gives you a true. So that's your main. Sometimes when I would do it, when I was in grad school, I'd circle that one. I'd circle all of them so I'd know that was the row. And then on this one, you got true dot true, which makes a true and a true and a true with this horseshoe right here will give you a true. Okay? And then you just do that with each row. You apply it. And so we say A, A is true here. B is true. C is false, which we know with the horseshoe makes this false and a false horseshoe true makes this horseshoe right here for this line false. And then you do that for over here. We know that the A is true, the B is true, and the C is false. And a true dot true is false. And a true horseshoe false makes a false. Okay? So you just keep doing that. A is true. B is false. C is true. A false horseshoe true is true, and a true horseshoe true is a true. Then, A is true. And like I said, working these with 3 variables or more get long and cumbersome. So we know A is true, B is false, and C is true. We know F dot true is false, and we know true horseshoe false is false. Okay. So now what we see here, and I want you to keep working the problem, even though you've discovered something. And here's what you've discovered, whether you know it or not. That is that this row right here proves that this argument up here, this argument right here is invalid, because you have a row here where you have all true premises right here and a false conclusion. Okay? But I want you to keep working. I want you to keep working the problem as you keep going. So, A's true, B's false, C's false. So that makes that true. And a true on a horseshoe is true. And then we know A's true, B's false, C's false. And we know that a false and a false make a false. And a false and a true horseshoe false makes a false. So it looks like, once again, we have another line that shows that this argument's invalid. You only need one line to prove that it's invalid. But we have another row or line that shows that it's invalid, because you have all true premises and a false conclusion. And you just keep going. The way this would work out would be that this would be true, 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 and true, without going through every single row and coming up with that, because we know here that would be false. A would be false, B would be false, true, C would be true, which would make that true. So you'd have a if false, then true, which makes this true, and then you just keep going all the way through. And that some of that's just to develop practice and to learn it. So with truth tables, that's what you're doing. With two atomic statements or variables, if you want to call them that, it's going to go quicker. And you're going to have just 4 lines. On this, you're going to have 8 lines, 8 rows. When you have 3, and then when you have 4, you're going to have 2 times 2 times 2 times 2, which 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So you're going to have 16 rows, which is just, it'll take you a long time to work that one out. And there's so much room for error there. So you're going to be asked to work some long ones. And part of that is practice. And part of that is learning more about, kind of embedding and learning more in your mind about what validity and invalidity is. And two, setting it up for next time that you can see how to do a abbreviated table, which are a lot quicker and a lot more fun. They're like puzzles. And so something I didn't mention before, especially getting into symbolizing English arguments, introducing truth tables, doing truth tables to test for validity. I always worked better from working with a real good pencil with a good eraser. That way I didn't have to scribble and write over the top of mistakes. I could erase them and my work could be clean, because the cleaner and more organized, the more you can kind of see where you are, and it helps your mind, I think, do the work. So I would say use a pencil and paper to work the problems. It'll save you some heartache and a lot of mess. And if you ever want to practice, we used to use small dry erase boards where you could just erase it, but that was before iPads and Apple Pencils. So that may be an option, which is what I do now. So I hope this helped. If you have any questions, feel free to contact me. Work through those problems, those exercise problems that are due, and always feel free to send me an email if you get hung up on something, if something doesn't look right or you don't understand, and we can set up a way to communicate some more through text, email, phone call, FaceTime, Zoom, to help you understand that. But I think what I've walked you through tonight, or today rather, what I've walked you through will helps you see the process in action, and then as you do it, you'll get better at it, and you'll learn better how to symbolize, and the nature of validity and invalidity, and the role of logical connectors in truth function, and just get more acquainted with deduction and logic by working these exercises and doing these truth tables to evaluate arguments for validity. So hope you have a great day, and just contact me if you need anything. Work on those assignments, get those in, continue to read through the chapter, and we'll see you next time.